All right, let's take a look at our sum and difference identities. So you have four different ones. Obviously, you have a sum for the sign, a difference for the sign, a sum for the cosine, and a difference for the cosine. So you need to pay particular attention to which angle is A and which angle is B when you're doing it. Most importantly, you need to know your ratios from those special triangles that we talked about in the unit circle. So I'm going to go through a couple of examples of each. So let's start with the cosine of 75. And for that, we're going to use the sum of cosine. Note in particular that the 45-degree family is used quite often. So with this, we're going to say the cosine of 75, we're going to split it to a sum. So let's say 45 degrees plus 30 degrees. And obviously we're going to be using the angles and the ratios that we know, so that would be 45, 30, 60, and the quadrangles, use 90, and 180, and so forth. So we split this to the cosine of 45 plus 30. We know, let's let A be 45 and B be 30. Yeah, if you flip them, your answer will ultimately come out to be the same thing. So no worries there. So we're going to now go the cosine of 45 times the cosine of 30 minus, notice the difference. When you have cosine and you're using sum, when you work it out, you're going to go minus the sine of 45 times the sine of 30. So cosine of 45, we know, is the square root of 2 over 2. The cosine of 30, being 1/2. No, I'm sorry, not 1/2. The square root of 3 over 2. Minus the sine of 45, being the square root of 2 over 2, times the sine of 30, which is 1/2. And we multiply these things, we get the square root of 6 over 4 minus the square root of 2 over 4. So ultimately, we can write our answer as the square root of 6 minus the square root of 2 all over 4. Okay, so that is the sum of a cosine identity. Now let's look at B. We have the sine of 165, and for that we are going to use the sum of sine. Okay? So for 165, we're going to say that we're going to use the sine of 120 plus the sine of 45. So we'll let 120 be A and 45 be B. So notice with sine, with the sum you got plus and plus, minus and minus. Whereas with cosine, they are opposites. Okay? So as we simplify this, we have the sine of 120 times sine of 120 times the cosine of 45 plus the cosine of 120 times the sine of 45. So the sine of 120 is going to be square root of 3 over 2. The cosine of 45 is going to be square root of 2 over 2 plus cosine of 120. It's going to be negative because it's in quadrant 2. So the cosine of 120 is 1/2, negative 1/2 rather. And the sine of 45 is square root of 2 over 2. So again, when we multiply them out, we're going to get the square root of 6 over 4 because we have that negative. It's going to be minus, you never write plus negative, so minus the square root of 2 over 4. And then again, write it as a single quotient as the square root of 6 minus the square root of 2 all over 4. Alright, now let's look at C. We have the sine of 105. So now let's do a difference. So let's do sine A minus B. So for 105, we're going to do the sine of 135 minus 30. So in this particular case, we'll let 135 be A and 30 be B. But again, the sine, notice you're still going to do a difference. So we're going to have the sine of 135 times the cosine of 30 minus cosine of 135 times the sine of 30. So sine of 135, again being in quadrant 2, you know it's going to be positive, is going to be the square root of 2 over 2. The cosine of 30 is going to be the square root of 3 over 2 minus the cosine of 135. And that is cosine in quadrant 2, so it's going to be negative square root of 2 over 2. And the sine of 30 is going to be 1/2. We'll multiply that out again. End up with the square root of 6 over 4. We have minus again, so we're going to say plus the square root of 2 all over 4. Again, you can write it as a single quotient, square root of 6 plus the square root of 2 all over 4. So I hope you're noticing a common theme here that we're getting a lot of the same numbers. It's just a matter whether it's positive or negative and how that comes about. So let's look at D, the cosine of 135. I'm sorry, 195. So for that, we're going to use a difference identity for cosine. So we're going to say cosine of 225 minus 30. Where we'll let 225 be A and 30 degrees be B. So let's take the cosine of 225 times the cosine of 30 plus the sine of 225, the sine of 30. So the cosine of 225, being in quadrant 3, it's going to be negative square root of 3 over 2. I'm sorry, square root of 2 over 2. cosine of 30 being the square root of 3 over 2 plus sine of 225. Also requires a 3, which will make it negative. Square root of 2 over 2. And the sine of 30, 1/2. So we multiply those out. We get negative square root of 6 over 4 minus square root of 2 over 4. So again, writing our answer as one quotient. Negative square root of 6 minus the square root of 2 all over 4. Okay. Take a few moments to try examples E, F, G, H on your own, and obviously you can check back to fill those in, and we'll move on to the next example. Let's take a look at your answers for examples E and F. Now, you could have used different angle values, but ultimately your answers are going to be the same. Okay? As long as, again, you have the correct math, correct sum or difference, then you should be in good shape. And here is the answers to G and H. So here is the first part of your notes for example 1 on sum and difference. Check back for the video on example 2.